All right, this video is going to teach you how to set up and solve titration problems. Essentially, what a titration is. Titration is just a neutralization reaction where you react an acid and a base until they completely neutralize one another. And so basically what you take is you'll take either an acid or a base of known concentration, so you know what its molarity is, and you use that to determine the concentration of an unknown acid or base. Okay, and so to do this, you usually use some kind of indicator, and these are chemicals that change color at the endpoint. So basically, like for example, with phenolphthalein, phenolphthalein in an acidic solution is clear, but if it goes into a basic solution, it turns bright pink. You saw that from the demonstration video I showed you with the titration there with what was it, Jared Hyman. So anyway, what we're looking at is a point where the moles of hydrogen ions and the moles of hydroxide ions are completely equal, and that happens at this thing called the equivalence point or the end point. This really isn't any different from things we've already done. So it's just incorporating, being able to write and balance a double replacement reaction. It deals with being able to convert or, calculate molarity, and then there's a little bit of stoich in it. So it's really kind of a culmination of things that we've been working on for some time. So first thing, as always, with any kind of stoich problem, you have to start with a balanced neutralization reaction, right? So you have to know how to predict products. And just remember, whenever you combine a acid and a base, they form salt and water. Then you have to be able to calculate the number of moles of the known, either acid or base. So generally what you'll be given is a volume and a concentration. Well, if you know volume and you know concentration, you know moles. Once you know the moles, you can convert moles of the known to moles of the unknown using a mole-to-mole stoich problem, a one-step stoich. And then finally, once you know the moles of the unknown, you know its volume. If you know moles and you know volume, you know its molar concentration. And that's it. So they're actually pretty straightforward. This would be an example of a stoich, not a solution stoich or a titration. Okay, it says I have 25 mils of a sulfuric acid solution is completely neutralized by 18 mils of a 1 molar sodium hydroxide. I want to know what the solution concentration is for that acid. First thing you have to do is have a balanced formula. So here's one of the reactants, sulfuric acid. Here's the other one, sodium hydroxide. Okay, and so like we've talked about before, H is going to go with the OH. So there's your water. Okay, and then the cation from the base goes to the anion of the acid. Sodium's 1 plus, sulfate's 2 minus, so it's Na2SO4. There is your formula equation. It isn't balanced, however, so this is where we have to get in here and balance this guy. What I would do, let's take a look here. We have 2 sodiums and 1 sodium and slap a 2 there. Now all you have to do is put a 2 in front of the water and you should be balanced. So there's our balanced formula. Okay, now what we're going to do, we're going to start with the one we know the most about. That's the, looks like the sodium hydroxide, the base. You'll recall molarity is moles of solute per liter of solution. Well, we know the molarity, 1.0 molar. We don't know the number of moles. The volume we do know, 18 mils. You realize that we have to make this liters, moles per liter, right? And so to convert milliliters to liters, you move the decimal place 3 places to the left. To solve this, we're going to cross multiply. And so when you do that, you end up with 0.0180. And this is going to be moles of NaOH. Now that we know the moles of NaOH, we're going to convert them to moles of sulfuric acid. So what we're going to do, we're going to start with what we know, 0.0180 moles of NaOH. And let's see. I guess technically if we were really doing sig figs, you'd get rid of this last 0 because this has 2. Not a huge deal. But anyway, 0.018 moles of NaOH, and according to the balanced formula, for every 2, I get 1. So I'm going to put 2 moles NaOH here, 1 mole sulfuric acid here. Okay, and that's telling me when I do this, I'm going to essentially divide. So this is going to give me 0.009, and I guess 0 moles of sulfuric acid. Okay, so that tells me the quantity of sulfuric acid that reacts with that quantity of base of the sodium hydroxide. Well, now I know the moles. Hey, I know the volume as well. I'm going to divide this by, and it has to be liters, so it's 0.0250 liters. So that's moles per liter. I grab my magic box, 0.009 divided by 0.025. When I do so, I'm going to get 0.36 molar. That is the concentration of the unknown acid. And that's all there is to it. So they're very repetitive. I'm going to show you another one, just another format. I'm going to give you guys some time or some of these to practice. I don't know if you saw this in the video or not, but this is going to show you, like, had we been together in class, we would have done an actual endpoint. It's actually pretty hard for me to do because I'm colorblind. So, like, on this part, the good endpoint, it is faintly pink. Like, I can't even really see it. I generally have to have somebody else kind of tell me when I've hit that. But what you have to understand, it's the difference between this and one drop. And I don't care if you put a drop in or 10 extra milliliters. It doesn't get any bright pinker than this. So, it's a skill. But you aren't actually going to get to drive the burette. All right, let's do this. So let's say I give you some information in a data table like this. This would be like something we would collect in a lab. And so you'll see I have initial volume and a final volume, both of an acid and a base. I know the concentration of the base. I do not know the concentration of an acid. Okay, well, and when you're doing this, you're reading that burette, that long, thin piece of glass where it has the stopcock on the bottom. Well, you don't have to start at 0.0, and this one I did, so that's pretty easy. All you have to do to tell how much of like this base was dispensed, just subtract the 2, so that's going to be 18.7 mils. Okay, and then when I do this, notice it was not at the 0 point, and it doesn't have to be because you're just trying to find the difference between these. Okay, so you start at 2.5 and you let it out until it went to 16.1. Well, that tells me you had 13.6 mils of that acid dispensed. So you have volume of both, the concentration of one, that's enough to solve it. Okay. So first thing, just as always, you got to have a balanced formula. And you have our acid and our base up there. So we have hydrochloric acid. We're combining this with calcium hydroxide. Okay. H is going to go with OH. There's your water. What's left over? Calcium and chlorine. So calcium's 2 plus, chlorine's 1 minus. It's CaCl2. Flop a 2 in front of there and probably a 2 here, and we should be good. Okay, so then this is just really like the other problem. We know a concentration and 2 volumes. So this one was I think that was the base, wasn't it? Yeah, the calcium hydroxide. So once again, the molarity is 0.0100 molar. We do not know the number of moles, but we do know the volume. 0.0187, that's 18.7 mils turned into liters. Okay, now all I have to do is I cross multiply. And so if I take 0.0187 times 0.01, this turns this into 0.000187. And this is going to be moles of calcium hydroxide. I want to turn those moles of calcium hydroxide for every 1 mole calcium hydroxide. It reacts with 2 moles of hydrochloric. So moles cancel, so I'm going to take that number and take it times 2. This is going to tell me I have 0.000374 moles of HCl. Well, I know the moles. Guess what else I know? I know its volume, 0.0136 liters. So I'm going to take that number and divide it by 0.0136 liters. And you're going to end up with 0.0275 molar HCl. And I think everything was 3 sig figs, wasn't it? Yeah, because the volumes, because notice this is a subtraction. So really the numbers we were calculating, there's 3 here, 3 here, 3 here. Our answer will have 3. Don't get real hung up and upset about the sig figs on this. But that's basically how you do it. I'll give you a couple or a few here to practice. You can practice them. We'll talk about them on Monday.